when that happens, the air conditioning units are still running on the train, right? So that they are still outputting hot air from the recirculation exhaust vents. And so we had to consider, was there sufficient tunnel airflow in order for us to say that there wouldn't be too much recirculation of hot air coming out from the condensing units, going back into the air conditioning inlets and causing problems with performance. The vents themselves, they were actually quite detailed cab. They had a number of louvers, and so it was considered for this case where we were modelling a long tunnel with 8 cars, it was going to be very expensive to model those explicitly. We worked out the flow direction for each of those, so there's the straightened flow that will be passing through those louvers. We were able to put in direction controls as boundary conditions there, and that enabled us to specify the inlets. So then we were able to consider temperature effects. Would we have 50-degree air going back in to the air conditioning units? If there was a significant amount of that could be a concern. I use it as a go-to for, would be for cases like this where perhaps you have specific lighting, you want to do some special tools like moving along the streamline, having the camera follow. You can enable rigid body motion, which is a way of rotating parts which are truly static. You know, that can definitely help when you're providing CFD as a visual aid to people who don't understand it all that well. And I'd say another large reason people will use Ensight is because of its case handling capabilities. So it can handle very large mesh sizes, typically hundreds of millions of cells are no problem.